Today we're going over the calculations for what you did in your lab for finding the specific heat of a metal. So let's suppose that you had some aluminum for your metal, and remember what you did is you heated it up in a beaker of really hot boiling water, and you found the temperature of this water, and you would heat it up on a Bunsen burner, of course. And then you had a styrofoam cup, and inside the styrofoam cup you had a specific amount of water. And then you took this hot metal and you added it to the cold water. And before you did that, you took the temperature of the water before, and then you took the temperature of the water after. So let's suppose that my data looks like this. Let's suppose I had 31.54 grams of the metal. Let's suppose that I had 100 grams, which was 100 milliliters of the water, the cold water. Let's suppose that my bath temperature was 100.5. So this was 100.5 degrees Celsius. This was 31.54 grams. Then we said that the water was 100 milliliters, which is the same as 100 grams, because the density of water is 1. Let's suppose that the temperature of the water was 21.8 degrees Celsius. And then let's say that after we added this, the final temperature went up to 27.0 degrees Celsius. So that means that the hot metal went down to this temperature and the cold water went up to that temperature. So now what we need to do, so let's put the distilled water temperature here is 21.8 in the data table. And then the final temperature we said was 27.0. So let's talk about the calculations of this lab. They're actually quite simple once you see the big picture. So the metal, which in my case was aluminum, has one of these drawings, and water also has one of these drawings. Now the temperatures are not going to be the same for water's boiling point and freezing point are not going to be the same as the metals, of course. But remember that the metal is a solid, so it's in this zone right here, zone 1. And the water is a liquid, so it's in zone 2. So the metal was hot, and then it got colder. The final temperature, actually, I'll put in black right here. And the water was cold, and then got warmer. So the final temperature in black is right there. So the water went up to 27.0 degrees Celsius, but it started at 21.8 degrees Celsius. And then the metal in my lab started at 27.0, it ended at 27.0 degrees Celsius, but it started at 100.5. And the reason why you knew the temperature of the water, of the metal, is because you knew the temperature of the water in the bath. Okay, so the temperature of the water in the bath was 100.5, which told you the temperature of the metal to start with. Okay, so now let's do our calculations. The MC delta T of the metal, which is the heat lost by the metal because it was hot, is equal to the distilled water heat gained. So we're assuming that all the heat lost is equal to the heat gained. So the metal is going to have, because it's in zone 1, an MC delta T, and the water in zone 3 is also going to have an MC delta T. And we know the specific heat of water is 4.18, and the whole point of the lab is what is the C value of the metal? What is the specific heat of the metal? So first we need the mass of the water on the right side, which is going to be 100.0 grams, because this is what I had in my data. I'm going to make a 100.0 there. All right, 0.0. Now we're going to look at the delta T of the water. The delta T of the water is going to be the difference between 27, the final temperature, and 21.8, which was the initial temperature. So the delta T of the water is going to be 5.2 degrees Celsius. You have to show your work for this when you type up your lab. So the delta T of the water, 5.2 degrees Celsius, and that would go under delta T. And then I need to know the mass of the metal, which I weighed in the beginning is 31.54 grams. That was on a scale. I don't know the C value of the metal. And then the delta T of the metal is going to be right here, which is 100.5 degrees Celsius minus that 27 degrees Celsius. And when you do the math for that, you're going to find out this comes out to be 73.5. So that's going to go right here. Again, you should show your work on your lab for that, 73.5 degrees Celsius. So that's going to be my delta T right here. Now you just do the algebra, and you find out you get 0.938, and that's joules per gram degree Celsius. Notice that this number, 0.938, is a much lower number than the water's specific heat, which is 4.18, which makes sense because it's really hard to heat up water and really easy to heat up a metal. So it has a very low specific heat. And now we just need to get our percent error. Percent error is the difference between the right one and what you got. And so you could see that the one you're supposed to get for the metal is right here, 0.910, and we got 0.938, which is not too far off. So you simply have to do the theoretical, 0.910, minus the experimental, 938. It actually doesn't matter what order because your absolute value on that. And then this is going to be over the right one, which is 0.910 times 100. And that's going to give you about a 3.0% error for my data.